Welcome back, students. In this particular video we will talk about full subtractors. Now full subtractors perform subtraction of three number of bits, and these three number of bits are being denoted as ABC. Now there is a terminology that we follow in subtractors, is like the first number from which you are subtracting the things is called as minuend, and the number that is being subtracted, that is called as subtrahend. And if you want to learn this by example, it is like a minus b operation is being done. So this a is called as minuend, and this b is called as subtrahend. And while we are subtracting, there might be a borrow also coming from the preceding column, so that is now third one. So these three are the inputs represented here, and similarly once we are doing the operation, there can be a borrow and as well as a difference. Now as far as the design procedure is concerned, our first step is clear, that we should know like how many number of inputs and outputs does the design problem have, and we have to assign certain names to it. So that step is done. So we will come to our next step, that is our truth table. Now considering that we have three number of inputs and two outputs, we are having how many combinations in total? For n number of inputs, possible combinations are 2 to the power n. Here we have 3 inputs now, so we are having 8 combinations, because that is 2 to the power 3. Again we will take it one by one, all the cases. So the operation that has been done here is like a minus b minus c. If we see the first case, 0 minus 0 minus 0, so all are 0, so obviously this one is simple. Similarly, let us try to cover these three. Alright, so what is 1 minus 0 minus 0? So again the difference will be 1, and there is no need of borrow here. So this is 1 with 0. Similarly, what is 1 minus 0 minus 1? So 1 minus 0 is 1, 1 minus 1 is 0. So again there is no need of borrow. So, and the last one is also easy, 1 minus 1 minus 0. So 1 minus 1 is 0, 0 minus 0 is 0. So this is 0 along with borrow, again 0. Now coming to the other cases which are left, suppose 0 minus 0 minus 1. So 0 minus 0 is 0, and what is 0 minus 1? If we will refer to the half subtractor, we have learned there 0 minus 1 is not possible, because the number as subtrahend is greater. So we will take borrow in this case. So whenever borrow is required, this has to be 1 here. So it becomes 1 0, 1 0 is 2, and 2 minus 1 is 1. So both the values are 1 1. Now the next case is also same, 0 minus 1 minus 0. So 0 minus 1 is not possible, it will take borrow, so it becomes 2, and 2 minus 1 is 1, so it will be 1 1. Now the next case, 0 minus 1 minus 1, is also interesting. Because 0 minus 1 is not possible in the first stage, you will take borrow. So borrow has been taken. So 1 0 becomes now 2. Now the operation is like 2 minus 1 minus 1. So what is 2 minus 1 minus 1? So it is 0. So this value is becoming 0. And finally the last one is what? 1 minus 1 minus 1. So 1 minus 1 is 0. So 0 minus 1, because this one is still there. 0 minus 1 already we have covered here. 0 minus 1 will be borrow 1, and 2 minus 1 is 1. So in this way this table has been completed. Now we will come to the third step of our design procedure, which is solving equations, okay, getting equations from K-map or Boolean algebra. So let us do it. Now you can see, students, the table is with us, and if you will look at the difference column, the output of the difference column, it is same as what we got as sum in full adder. You will notice that the summation was like the ones were present at these particular positions for sum in a full adder, and exactly same thing is here also. This is 1, this is 2, this is 4, and this is 7. So the rule is, whenever the min terms are at same position, the equation we will always get is same. This is what I said in the previous video also regarding the sum and the difference equation was same for half subtractor. Similarly here, if we talk about the sum, and the difference, they are again same for full subtractor also. So we don't need to solve it, we can directly write here difference is equal to, equation is what, A XOR B XOR C. And still, if you want to know how it comes, I would advise you to refer to the video of full adder. You will get like how this equation was coming. Now we will come to the borrow equation. In borrow equation, let us see where are the min terms. First of all, in borrow, the min terms are available at positions, you can see 1, 2, 3 and 7. 1, 2, 3 and 7. We will write 1, 2, 3 and 7. Now we are using K map, and you know the positions. This is 0, 1, 3, 2, this is 4, 5, this is 6, this is 7. So these are the positions. Now at these positions we have to fill 1. So let us do it. This is at 1. I should change the color. This is at 1, then 2, then 3 and 7. Now we have to create groups in such a way that all the ones are occupied. So if you see this one, the answer is BC. Now there are more possibilities of group. So let us take one more group, that is here. These two can be also a group, and the answer will be A bar with C. And the 1 is also there on the right hand side. So we have to create one more group of these two ones, and the answer is A bar with B. So that is our answer. We can then say borrow equation is A bar B plus BC plus A bar C. And if you will compare it with the carry equation of full adder, this is for full subtractor. I am just comparing the things with the you can say full adder. It was last time AB plus BC plus AC. So only difference is that the A we are having right now in borrow, that is complemented. Last time there was no complement, and right now it is complement on A. The rest is again almost same. So finally, the last step of our design procedure is the logic diagram. So before we go to the logic diagram, let us revise 2 points. That difference equation was A XOR B XOR C, and the borrow equation was A bar B plus BC plus A bar C. Now as far as the diagram is concerned, we can have a diagram like this for our difference first of all. So this can be A and B, and then we will give one more input from here. So this will be my difference. So this was A XOR B, and this is my input C. So this difference is equal to A XOR B XOR C. Now coming to the borrow, we need 3 AND gates and OR gate. So we can have 3 AND gates here, 3 AND gates and OR gate also, which will give us the final output. So this is my borrow. Now the first term is A bar B. So how will we do A bar B? This is A bar with B. Then we have BC. So B is already here, and this is my C, and A bar C. So A bar is already available here. So A bar along with C. So we are having C here. So student, this is A bar B, this is BC, this is A bar and C. So finally this borrow is equal to A bar B plus BC plus A bar C. Okay, this being the OR gate being used over here. So that completes all the 4 steps regarding full subtractor. In our next video, we will see how can we implement full subtractor using half subtractors only. So I will see you in the next video. Till then, God bless you all and have a nice time.